connecting to the grounding electrode conductor, also known as the GEC for telephone or cable companies when using a combined entrance enclosure, referred to as a CE, without an outside accessible point of connection involves understanding the responsibilities outlined by the authority having jurisdiction, often called the AHJ. The AHJ interpretation of codes and local requirements can vary, so it is crucial to verify the specific regulations in your area before proceeding. Typically, the responsibility for providing a connection point for telephone and cable companies falls on the utility companies themselves, not the electrical contractor. However, if the local AHJ mandates that the electrical contractor provides the connection point, then adherence to this requirement is necessary. Before taking action based on a single interaction with the AHJ, further research into the specific code requirements and local interpretations is advisable. This research could involve firstly reviewing local amendments to the National Electrical Code, secondly contacting the AHJ for written clarification of the requirement, and thirdly discussing the issue with other electrical contractors in the area to understand their experiences and interpretations. If the AHJ confirms that the electrical contractor must provide the connection point, there are several methods to consider. The goal is to provide a safe and code-compliant connection that also maintains a professional appearance. One approach is to install a grounding electrode conductor from the main electrical panel to a point accessible outside the building. This might involve using a number 6 AWG copper conductor, as suggested, or another size conductors required by the National Electrical Code, specifically Table 250.66. Based on the size of the service entrance conductors. This conductor should be connected to the grounding electrode system, which may include a ground rod, underground metallic water pipe, concrete encased electrode, or ground ring, in accordance with NEC Section 250.52. To maintain a professional appearance, the grounding electrode conductor can be routed through a protective conduit or sleeve where it penetrates the building's exterior. This protects the conductor from physical damage and weathering, and it provides a clean, organized look. The point where the conductor exits the building can be sealed to prevent water ingress and insect intrusion. Several options exist for creating an accessible connection point outside the building. One option is to install a grounding busbar or terminal block in a weatherproof enclosure. The grounding electrode conductor from the panel can terminate on this busbar, providing a convenient and accessible point for the telephone or cable company to connect the grounding conductor. The enclosure should be listed for outdoor use and properly secured to the building. Another option is to use a listed grounding electrode clamp specifically designed for direct burial or outdoor use. This clamp can be attached to the grounding electrode conductor where it exits the building, providing a secure and reliable connection point. The clamp should be protected from physical damage and corrosion. Regardless of the method chosen, it is essential to ensure that the connection is properly made and that all components are listed for the intended use. The connection should be accessible for inspection and maintenance, and it should be protected from physical damage and environmental factors. It is also important to coordinate with the telephone and cable companies to ensure that the grounding conductors are properly sized and installed. They should follow their own internal standards and any applicable industry best practices for grounding and bonding. When routing the grounding electrode conductor, consider the following. Firstly, minimize bends and splices in the conductor. Sharp bends can increase impedance and reduce the effectiveness of the grounding system. Splices should be avoided if possible, but if they are necessary, they must be made with listed connectors suitable for the purpose. Secondly, protect the conductor from physical damage. Route the conductor in a location where it is unlikely to be damaged by vehicles, equipment, or other hazards. Use conduit or other protective measures as needed. Thirdly, ensure that the conductor is properly supported. Secure the conductor to the building structure at regular intervals to prevent sagging or movement. Use listed supports and fasteners suitable for the application. Fourthly, maintain separation from other conductors. Avoid running the grounding electrode conductor in close proximity to power conductors or communication cables. This can reduce the risk of interference and ensure the integrity of the grounding system. Fifthly, properly identify the conductor. Label the grounding electrode conductor at regular intervals to indicate its purpose. This helps prevent accidental disconnection or modification of the grounding system. Sixthly, document the installation. Keep a record of the grounding electrode conductor's routing, connections, and materials used. This documentation can be helpful for future inspections and maintenance. Regarding the grounding electrode conductor size, the NEC specifies the minimum size based on the size of the service entrance conductors. Refer to NEC Table 250.66 to determine the appropriate size. For example, if the service entrance conductors are number 2/0 AWG copper or number 4/0 AWG aluminum, the minimum size grounding electrode conductor for connection to a ground rod, ground plate, or concrete encased electrode is number 6 AWG copper. For connection to a metal underground water pipe, the grounding electrode conductor must be at least number 4 AWG copper. When dealing with combined entrance enclosures, it's crucial to ensure proper separation of power and communication conductors. The enclosure should be designed to maintain isolation between the power and communication sections, preventing interference and ensuring safety. The grounding electrode conductor should be connected to the appropriate grounding point within the enclosure, as specified by the manufacturer's instructions and applicable codes. In addition to the grounding electrode conductor, bonding conductors may also be required to connect metallic components of the electrical system and communication systems. Bonding helps to equalize potential and reduce the risk of electrical shock. Refer to NEC Article 250 for specific requirements regarding bonding. It is also important to consider the impact of the grounding system on other electrical systems in the building. A properly designed and installed grounding system can help to improve the performance and reliability of sensitive electronic equipment, while a poorly designed system can cause interference and other problems. Consult with a qualified electrical engineer or grounding specialist to ensure that the grounding system meets the needs of all electrical systems in the building. Always consult the latest edition of the National Electrical Code and local amendments for specific requirements regarding grounding and bonding. The NEC is updated every 3 years, so it is important to stay current with the latest changes. Also, be aware of any local ordinances or regulations that may be more stringent than the NEC. In summary, providing a connection point for telephone and cable companies involves understanding the responsibilities outlined by the AHA, conducting thorough research, selecting appropriate materials and methods, and adhering to all applicable codes and regulations. By following these guidelines, you can ensure a safe, code-compliant, and professional installation.